All right, so we're going to pick up where we left off last class. So last class we were talking about how to combine ions, and there was only one possible way to combine them. For instance, if we talked about calcium combining with chloride, calcium is a +2, right, on the periodic table. Chloride is a -1. Now I'm calling this chloride and not chlorine because chlorine is an element with no charge. Chloride is an element with a charge, aka an ion. So, right, if we want to combine a +2 and a -1, they would have to go together like this, right? So if I just kind of sketch those in there real quick, because the two -1s are required to cancel out that +2, right? Another example would be if I had the aluminum ion and the oxide ion, where aluminum, again, off that periodic table, is a +3, oxide is a -2, so the only way for them to cancel each other is if you turn them both into a 6, meaning you have 2 aluminums to give us a +6, and you have 3 oxygens to give us a -6. So that's how those would combine. Now, naming these is actually really easy, because all you do is you say the name of the positive ion, calcium, and then you say the name of the negative ion. The only thing to remember is when it's an ion, it ends in ide, IDE. So this is calcium chloride. This is aluminum oxide. Right? That's all we're doing here. Right? So, you know, everybody's favorite rock to eat, NaCl, right? This is table salt. Just say the positive, sodium, and then add I to the negative, chloride. Maybe you have some of this, I don't know why you would, aluminum and nitrogen put together, right? This would be aluminum nitride. That's it. Now, some people get really confused and caught up on where and how to add the ide. Generally, it's after the first syllable, right? So nitride, right? Nitrogen has 3 syllables, so you actually cut off the last 2. Whereas like chlorine just has 2 syllables, so it's, you know, it's easier. Phosphorus also has 3 syllables, so it's phosphide, right? So it's oxide, chloride, nitride, phosphide. You know, a lot of chemistry teachers, they're not going to be too upset if you don't quite have this down. Some will, everyone's different. But, you know, for me, if you accidentally were to call this like phosphoride, as long as you're showing me that you know the I goes at the end, I think you'll pick it up, okay? Now, this is the easy way. It gets a little harder if you have to go the other way. And what that means is I give you the name and you have to give me the formula, which really is just exactly what we did last week. That's all we did last week, right? So for instance, if I give you lithium sulfide, and I say, please write the formula for lithium sulfide. So what you're going to do is you're going to write out your lithium and you're going to write out your S. You're going to go to the periodic table and you're going to find that lithium is a +1 and sulfide is a -2. So therefore you need 2 of those +1s to cancel out that -2. So lithium sulfide would be Li2S. Let's keep doing more examples. What about if I give you calcium oxide? Right? Same thing. Write out the calcium, write out the oxide, find calcium on the periodic table, it's +2. Oxide on the periodic table, -2. So nothing needs done, they already cancel. Calcium oxide is CaO. What if I do potassium phosphide? Right? Same thing. Periodic table. Potassium is K, phosphide is P, potassium is a +1, phosphide is a -3, so you need 3 of those +1s to cancel out that -3. All right, and that's it for the easy version. Now, next up's the hard version. So the whole reason we could put these together, right, like this, the whole reason I knew that lithium sulfide was Li2S and calcium oxide was CaO and potassium phosphide was K3P, the whole reason we knew that was because we knew the charges. Potassium is always a +1, phosphorus is always a -3, so that's the only way they could possibly go together. +2, -2, only way they could possibly go together. But if instead we talk about the elements in the middle, the transition metals, right? All of these guys here in the middle, they actually have multiple charges, multiple possible charges. So what that means is you can't just say iron oxide. You can't just say, tell me the formula for iron oxide, because you're going to go and say, okay, well, iron is Fe and oxide is O, and oxide is a -2 and iron is a O. I don't know. I don't know the charge of iron. Right? It's right here in this middle section. And Mr. St. Germain taught me this column and this column and this column and these 3 columns, but he didn't talk about any of the stuff in the middle, so I have no idea how they go together. And you're right, you don't, and there's no way you could. So the name, just the name iron oxide is not enough information to be able to figure it out. So what we have to do is we have to tell in the name itself what the charge of that metal is. So, for instance, we can say iron 2 oxide, right? So now this tells me the charge on my iron. So when I go to write this out, I'm like, okay, I need iron and I need oxide. I look on my periodic table and know that oxide is a -2. And I look right here to know that iron is a +2. This tells me that iron is a +2. So in this instance, this one works out. +2, -2, perfect. Now, if we do this one instead, iron 3 oxide, you're going to do the same process. Write down your iron, write down your oxygen. You know oxygen is a -2 based on the column on the periodic table. Now iron is a +3 in this instance, which again you know from that Roman numeral 3. So now you need to make a 3 and a 2 cancel out. We're going to do it the same way we've been doing it, where you have 2 of the iron and 3 of the oxygen. So you can see there's a big difference between iron 2 oxide, which is just 1 iron and 1 oxygen, versus iron 3 oxide, which is 2 iron and 3 oxide. But the biggest thing to remember is, the biggest mistake people make is they forget that the Roman numeral is the charge on the metal. The Roman numeral is the charge on the metal. The Roman numeral is not one of these numbers, okay? It's the charge on just the metal. So let's do another example. For instance, we could do tin 2 oxide. So same thing. You're going to write your tin, you're going to write your oxide, you're going to find oxide's charge on the periodic table is a -2. This 2 right here tells you that the charge on the tin is a +2. So they're going to cancel just like that. All right. Let's do one more. Copper 1 sulfide. So again, gonna have your copper, gonna have your sulfide. Periodic table tells you that sulfide has a charge of -2. This Roman numeral tells you that copper has a charge of +1. So you need 2 of those +1s to cancel out that -2. So this would be copper 1 sulfide. All right, let's get a new page here and do the last part, which is just doing it the other way, right? So we just did where I give you the formula. I'm sorry, I give you the name and you give me the formula. Now we have to do the thing where I give you the formula and you give me the name, which, just like in the other one, is a little trickier. So, for instance, here's how this is going to work, right? If I give you this, all right, you immediately find Ni is nickel, it's in the middle. So you know you're going to need Roman numerals. So how I like to do it is write out nickel phosphide and just leave myself, I forgot an H, it's there, I promise. Leave myself that spot for that Roman numeral. All right, that's it, leave myself that spot. So now I need to figure out the charge. Now, because it's attached to one that you know the charge of, right? It's attached to a -1 that you know the charge of, you can figure out the positive charge. So for instance, phosphorus, you look on your periodic table, phosphorus is -3. Because they're attached in a 1-to-1 ratio like this, right? That means that whatever this nickel is, it must cancel out this phosphorus. So that means this nickel must be a +3. So this is nickel 3 phosphide. All right, let's do some more. Here's another one, CuS. So same thing. How I like to do it, I know it's copper. I know I'm going to need a Roman numeral because it's in the middle. And I know it's sulfide. So same thing. Sulfide is a -2. You find that on the periodic table. So since they cancel out, that must mean that this copper is a +2, which means this must be copper 2 sulfide. All right. Here's another one, Ag3N. Again, silver some Roman numeral nitride. You know the nitride is a -3 because of the periodic table. So that means that all these silvers together must total a +3. And since there's 3 of them, that means that each individual must be a 1. So 3 +1s will cancel out 1 -3. So this is silver 1 nitride. All right, we'll do one more. Let's do this, the hardest one I can give you. Let's end on the hard one. So again, we know that this is iron, and we're going to need a Roman numeral, phosphide. Phosphide is a -3. All right, so we have 2 -3s. So that means this whole side, if we want to kind of think about it like halves, and I didn't mean to draw over that 3, but if we want to kind of think about it in halves, this whole side is a -6. All right, we have 2 -3s. So that means this whole side has to be a +6. So they cancel each other out. So 3 what's will give me 6? Well, 2. So that means this is an iron 2 phosphide.